Well, hello there. Sion Batson here from Sion Batson Tutoring. And in this video, we will continue solving two-step equations. This is part 2 of the series. If you have not seen part 1, please pause this video and go watch part 1 first before you continue with this lesson. In part 1, we discussed all the key details that will help you master the skill of solving a two-step equation. In part 1, we discussed what the ultimate goal is when solving a two-step equation. We also discussed the process, the steps, and we even solved a few basic two-step equations. So please go watch part 1 first. Learn all the basics that will help you master the skill of solving a two-step equation. And when you feel comfortable with the concept, come back and join us. Got it? Perfect. Now, let's continue. Your assignment from part 1 was to solve this equation for m. So, let's solve for m, or find the value of the m. To solve for m, we will have to isolate this m. In other words, we have to get this m positive and all by itself on the left side of the equation. To isolate this m, we will have to get rid of some unwanted terms. Yes? We will have to get rid of this negative 5 and this positive 13. Look at that. If I get rid of the negative 5 and the positive 13, m will be positive and all by itself on the left side of the equation. The question is, which of the unwanted terms should I get rid of first? Should I get rid of the negative 5 first, which is multiplying the m? Because remember, negative 5m is the same as negative 5 times m. Or should I get rid of the 13 first, which is adding to the m? Well, remember, step 1 tells us that the unwanted term that we get rid of first will either be adding to or subtracting from the variable. In this example, the 13 is adding to the m. Therefore, we will get rid of the 13 first. Yes? The question is, how will we get rid of this 13? Well, since the 13 is adding to the m, we will subtract 13 to get rid of the 13. Because remember, to get rid of an unwanted term, we will use its inverse operation. And the inverse operation of addition is subtraction. Yes? So let's subtract 13 to get rid of our 13 here on the left side. Remember though, if I subtract 13 from the left side, I must do what? Subtract 13 from the right side as well. Because to keep the equation balanced, we must perform the same operation on both sides of the equation. Yes? Let's subtract 13 and see what's left. 13 take 13 will give us 0. And that's the purpose of the inverse operation. It eliminates the unwanted term. After subtracting 13 on the left side, we're left with just negative 5m. Let's subtract 13 on the right side now. Minus 17 take 13 will give us negative 30. Yes? Negative 17 minus 13 will give us negative 30. Remember, whenever we are adding or subtracting integers that have the same signs in front of them, we will add the integers, then keep the sign that is in front of the bigger integer. Yes? So in step 1, we subtracted 13 from both sides to get rid of this positive 13, which is our first unwanted term. After step 1, we left with negative 5m equal to negative 30. But we aren't finished though. Yes? Remember, the goal is to isolate the m. The goal is to get this m positive and all by itself on the left side of the equation. The m is still not by itself. Yes? we still have to get rid of a second unwanted term to get this m positive and all by itself. If I get rid of this negative 5, the m will be positive and all by itself, yes, on the left side. To get rid of this negative 5, I will divide by negative 5. Why? Because remember, this negative 5 is multiplying the m. Because again, negative 5m is the same as negative 5 times m. And to get rid of an unwanted term, we have to use its inverse operation. And the inverse operation of multiplication is division. Yes? Therefore, we will divide by negative 5 on the left side to get rid of this negative 5. If I divide by negative 5 on the left side, I must do what? Very good. I must divide by negative 5 on the right side as well. Let's divide by negative 5 and see what's left. Negative 5 divided by negative 5 will give me positive 1. So after dividing by negative 5 on the left side, we're left with just 1m or just m. Because remember, 1m and m, they are the same term. On the right side, negative 30 divided by negative 5 will give us positive 6. So after step 2, where we divided both sides of the equation by negative 5, our m is finally isolated. Yes? M is positive and all by itself on the left side of the equation. M is equal to 6. Did you get 6? Oh, very good. How are you guys feeling? This is fun stuff. This is exciting stuff. I'm so proud of you guys. So proud of you. Very good. Job well done. Job well done. Now, let's keep the party going, yes? We have negative 19 is equal to negative 5 plus 7k. And in this equation, we will solve for k. Yes? Now, to solve for k, or to find the value of the k, we will have to isolate the k. In other words, we have to get this k positive and all by itself on the right side of the equation. To isolate the k, we will have to get rid of this negative 5 and the positive 7. Look at that. If I get rid of the negative 5 and the positive 7, k will be positive and all by itself on the right side of the equation. The question now is, which of these unwanted terms should I get rid of first? Should I get rid of the negative 5, which is taken from the k? Or should I get rid of the 7, which is multiplying the k? Remember, 7k is the same as 7 times k. Yes? So which unwanted term should I get rid of first? Now, just in case you are unable to see that this negative 5 is taken from the k, we can rewrite the right side of the equation as 7k minus 5. Yes? So the 5 is taken from the k. So again, which of the unwanted terms should we get rid of first? Well, remember, step 1 tells us that the first unwanted term that we should get rid of will either be adding to or subtracting from the variable. In this example, the 5 is taken from the k. Therefore, we will get rid of this negative 5 first. Yes? How will we get rid of the negative 5? Well, since the 5 is taken from the k, we will have to add 5 to get rid of the 5. Because remember, to get rid of an unwanted term, we have to use its inverse operation. And the inverse operation of subtraction is addition. Yes? So we will add 5 on the right side to get rid of this negative 5. If I add 5 on the right side, I must do what? I must add 5 on the left side as well. Remember, we have to keep the equation balanced. So whatever operation you do to one side of the equation, you must perform that operation on the other side of the equation as well. Yes? So let's add 5 to both sides and see what is left. Yes? Negative 5 plus 5 will give us 0. So the negative 5 is gone, and we're left with just 7k on the right side. On the left side, negative 19 plus 5 will give us negative 14. Yes? So after step 1, where we added 5 to both sides of the equation, we left with negative 14 is equal to 7k. But we aren't finished though. Remember what the ultimate goal is. The ultimate goal is to isolate the k. We have to get the k positive and all by itself on the right side of the equation. To isolate this k, we have a second unwanted term that we have to get rid of, yes? Which is the 7. Look at that. If I get rid of the 7, look at the k. It's positive and all by itself on the right side of the equation. How do I get rid of this 7 though? Well, to get rid of this 7, I will divide by 7. Why am I dividing by 7? Well, first, this 7 is multiplying the k. Because remember, 7k is the same as 7 times k. And to get rid of an unwanted term, we have to use its inverse operation. And the inverse operation of multiplication is division. Very good. So we have to divide by 7 to get rid of that 7 right there. And if I divide by 7 on the right side, I must do what? Very good, my friends. I must divide by 7 on the left side as well. So let's divide by 7 on both sides and see what happens. 7 divided by 7 will give us 1. So after dividing by 7 on the right side, we have 1k. Or just k. Because remember, 1k and k, they are the same terms. And on the left side, negative 14 divided by 7 will give us negative 2. Yes? So after step 2, where we divided both sides of the equation by 7, we were finally able to isolate the k. K is positive and all by itself on the right side of the equation. This k is equal to negative 2. How was that? This is fun stuff. And again, I want you guys to see that a two-step equation is called a two-step equation because it takes only 2 steps to isolate the variable. How are you guys feeling? This is fun stuff. We're going to do one more. We're going to do one more. And then it will be your turn to shine. Let us try n divided by 2 minus 10 is equal to negative 6. And we will solve for n. Or find the value of n, yes? To solve for n, we will have to isolate this n. In other words, we have to get this n positive and all by itself on the left side of the equation. To isolate this n, we will have to get rid of some unwanted terms. If I get rid of this 2 and the negative 10, n will be positive and all by itself on the left side of the equation. The question now is, which of the unwanted terms should I get rid of first? Should I get rid of this 2, which is dividing the n? Because remember, n over 2 is the same as n divided by 2. Because the line in the middle is also a division sign. So, should I get rid of the 2 first, which is dividing the n? Or should I get rid of this 10 first, which is subtracting from the n? Well, remember, step 1 tells us that the first unwanted term that we should get rid of will be either adding to or subtracting from the variable. In this example, the 10 is subtracting from the variable. Therefore, we will get rid of this 10 first. To get rid of this 10, I will add 10. Why am I adding 10? Well, remember, to get rid of an unwanted term, we have to use its inverse operation. And the inverse operation of subtraction is addition. Yes? So I have to add 10 on the left side to get rid of that 10. Yes? Now, if I add 10 on the left side, I must do what? add 10 to the right side as well, because we have to keep the equation balanced. And to keep the equation balanced, we must perform the same operation on both sides of the equation, yes? Let's add 10 to both sides and see what's left. Negative 10 plus 10 will give us 0. So the negative 10 is gone, yes? So after adding 10, we're left with just n divided by 2 on the left side. On the right side, let's add 10. Negative 6 plus 10 will give us 4. Yes? So, after step 1, where we added 10 to both sides of the equation, we're left with n divided by 2 is equal to 4. But we aren't finished. Remember, the ultimate goal is to isolate the n, or the ultimate goal is to get this n positive and all by itself on the left side of the equation. The n still has some company, yes, which is the 2. We have to get rid of this second unwanted term, the 2, to isolate the n. Look at that. If I get rid of the 2, the n will be positive and all by itself on the left side of the equation. How will I get rid of this 2? Well, remember, the 2 is dividing the n. Therefore, I will multiply by 2 to get rid of this 2. Again, remember, to get rid of an unwanted term, we have to use its inverse operation. And the inverse operation of division is multiplication. So I will multiply on the left side by 2 to get rid of this 2. If I multiply on the left side by 2, I must multiply on the right side by 2 as well. Remember, we have to keep things balanced, yes? So let's multiply both sides by 2 and see what's left. N divided by 2 times 2 will give me just n, because the 2 in the numerator here will cancel the 2 in the denominator. So we're left with just n on the left side. On the right side, 4 times 2 will give me 8. So after step 2, where we multiplied both sides of the equation by 2, we were finally able to isolate the n. Yes, the n is now positive and all by itself on the left side of the equation. N is equal to 8. How are you feeling? This was fun stuff. This was exciting stuff. Now, quickly, let's talk about step 2 here and the left side of what happened to step 2. We have n divided by 2 times 2. This is the same as 2 over 1. So if you want to multiply to see what's really happening, n times 2 will give you 2n, and 2 times 1 will give you 2. And if you simplify 2n divided by 2, these 2 will cancel out and you get n. Yes? But I just want you guys to see what is really taking place, yes? All right. How are you guys feeling? This is fun stuff. All right, so guess what? Your assignment will be to solve for v. Your equation is negative 2 is equal to 2 plus v over 4. I want you to solve this equation for v, and we will solve it together in part 3 of the series, yes? I hope you guys enjoyed this video. Until next time, enjoy your math practice and your math homework. See you.